All right, welcome back. Today, we're jumping right into a really fascinating clash of ideas, something that challenges how we even think about scientific truth.
So let's just get right to the heart of it, with the one question that really frames this whole discussion. And it's a big one. How do you prove a theory that you can't actually test? Something that might be totally beyond our current ability to even observe it. And look, this isn't just some late-night philosophical question. It is at the center of a very real debate happening right now.
Now, at the heart of this whole thing is a body of knowledge known as the Vedic Rashmi Siddhant. And its supporters, well, they're up against a huge challenge for modern science. I mean, a challenge that really gets to the very core of what we even consider to be proof. So this is the exact question that gets thrown at the theory's supporters. You could almost call it the gatekeeper question for all of modern science, right? If you can't test it, if you can't measure it, if you can't build a mathematical model for it, how on earth can you call it scientific? I mean, it sounds like a done deal, a total knockout argument. But the way they respond is where this gets really interesting.
See, instead of trying to come up with some new experiment, the proponent just completely flips the script. They build their entire case, not by trying to tear down science, but by using the words of some of the most famous scientists in the world to question whether the scientific method is as foolproof as we think it is.
They kick things off with none other than Stephen Hawking. I mean, Hawking himself said that any physical theory, no matter how solid it seems, is always provisional. It's really just a hypothesis. You can run a million experiments that support it, but that doesn't prove it's true. It just means you haven't managed to prove it's false.
Yeah.
And then they bring in Albert Einstein. He had that classic line, right? He basically said that no amount of experiments can ever prove him right, but a single one could prove him wrong. The point they're making here is that experiments, they're not there to give us absolute final proof. They're there to test things, to poke and prod a theory and see if it breaks. One little crack can bring the whole structure down, but all the success in the world doesn't make it a law for all eternity. This whole idea was actually formalized by the philosopher of science Karl Popper. He called it the principle of falsifiability. So the argument being made is this: if the gold standard of science itself says you can only ever disprove a theory, not prove it, well then how can you turn around and demand absolute proof for a new theory? You're asking for something that science admits it can't deliver for any theory, old or new. Okay, so after questioning experiments, the critique pivots over to mathematics, and here they use the words of Richard Feynman. He pointed out that math, it's a perfect, totally logical system. But the real world, it's messy, it's complicated. So the question they're raising is a pretty deep one. If math is just this perfectly clean model that we're trying to apply to a messy reality, how can we possibly say it's the final judge of what's true? All right, so if you start to question whether experiments and math are the only ways to validate a theory, what's left? What's the alternative? Well, after challenging the whole framework, the proponent puts a totally different standard on the table for how their theory should be judged. The first part of their answer is actually pretty practical. They're basically saying that their theory deals with forces and elements that are so incredibly subtle that our current technology just can't see them. Our tech relies on things like photons and electrons. They argue it's like trying to measure an atom with a ruler from your desk. The tool is just too crude for the job. So the big question is, how do you build trust in something you can't directly see? Well, they use this really clever analogy. Picture a student in a math class looking at a bunch of trigonometry formulas. To them, it's just gibberish. They have no reason to believe it's true. But then, the teacher uses those exact formulas to solve a real-world problem, like calculating the exact height of a plane flying overhead. All of a sudden, the student is a believer. Why? Not because they saw the formula in a lab, but because it worked. It actually solved a real problem. And that brings us right to their proposed standard of proof. This is really the heart of their counteroffer. They're saying, look, forget about direct observation for a minute. A theory proves its worth if it can take a problem that has completely stumped modern physics, one of those big ones scientists are spending billions to solve, and provide a logical, step-by-step solution. In their view, practical problem solving is the proof. But the argument doesn't just stop at the scientific method. No, it gets bigger. It expands into a full-blown critique of the institutions of science itself, specifically the whole system of getting published in peer-reviewed journals. And this is a direct quote from the source material, and it's pretty provocative. The proponent says that being forced to write short research papers is, in their words, a sign of slavery to Western countries. They don't see it as a neutral, objective process at all. They see it as a kind of cultural and intellectual surrender, forcing them to play a game with rules that are totally alien to their own tradition.
So this really lays out the two different worlds they're talking about. On one side, you've got the modern Western approach. You write short papers on small, incremental findings, and they get judged behind closed doors by a few journal editors. But on the other side, they describe the Vedic tradition. This is centered on grants, which are these massive, comprehensive books that lay out an entire system from the ground up. And how are they validated? Through Shastras, an open, public, scholarly debate. And to prove this isn't just some abstract complaint, they point to a real-world example from a news report. It's about how respected scientists, including the astrophysicist Jayat Narlikar, apparently faced censorship from major journals just for challenging the Big Bang Theory. So their argument is pretty simple. Hey, if the system can shut down established scientists for questioning a mainstream idea, what possible chance does a completely different, ancient theory from another tradition even have?
This all leads the proponent to ask one last very pointed question. How can the scientific establishment today act as judge and jury over a system of knowledge when, from their perspective, the judges don't even know the basic alphabet of that system? They're saying that to just accept that judgment, well, that would be a complete intellectual surrender.
So, where does all this leave us? I mean, what do we take away from this really deep and pretty challenging debate? We've gone on a journey here, from questioning the nature of scientific proof itself to the culture of how we share and validate knowledge. Let's just quickly recap the main arguments we've heard.
Okay, first, we heard the argument that science's biggest names, people like Hawking and Einstein, admitted that you can't really prove a theory. You can only disprove it. Second, we were offered a different kind of proof, that a theory is valid if it can logically solve a problem that today's science can't. Third, the whole peer review system was presented as a kind of culturally biased gatekeeper, not a neutral playing field. And finally, we saw that stark contrast between two traditions of knowledge, the modern world of short research papers versus a tradition of huge scholarly books and open public debate.
And this really leaves us with one last huge question. And it goes way beyond this specific theory. When a new system of knowledge, or like in this case, a very ancient one, comes face to face with the established way of doing things, who gets to write the rules? Who decides what counts as proof? It's a fundamental question, really. It's about power, it's about culture, and it's about how we as humans decide what's true.